The most effective way for fighting and protecting ourselves from novel coronavirus is to maintain social distance. Therefore, in this video, I Love Gupta will take you through a complete process of making an effective social distance detector. A person with just little knowledge about Arduino microcontroller and with basic programming skills can easily make this detector and thus effectively maintain social distance. So let's get started. First of all, let's have a look on the circuit and the connections made. I will give you a brief description about all the components used for making of this circuit. This is the Arduino UNO. It is a microcontroller based on Atmega 328. It has 20 digital pins, 60 MHz resonator, USB connection, a power jack, ICSP header, and a reset button. The next is the ultrasonic sensor HCSR04. It is a distance sensor and is used for detecting the distance of an object using sonar. The transmitter emits a high-frequency ultrasonic sound which bounces off any nearby solid objects and receiver listens for any return echo. Here is the buzzer. It is an audio signaling device. It includes oscillation circuit and the piezoelectric elementer speaker, which, when a voltage is applied, creates a buzzing sound. Here is the 5 mm LED. These are exceptionally bright with a wide beam angle, so they are suitable for use in projects. Also, they use low power. Now, if we talk about software used for simulating this circuit, it is Tinkercad. Tinkercad is a free online simulator which is easy to use. It is also used for 3D modeling. So here in this circuit, the sensor has 4 pins. The VCC pin is connected to the 5-volt pin of the Arduino. The trigger is connected to the digital pin 6. Echo pin is connected to Arduino's digital pin 5. Ground pin is connected to the ground pin of Arduino. The buzzer negative and the LED positive are connected to the ground of the Arduino, while the buzzer positive and the LED negative are connected to the 13 pin of the Arduino. Now let's have a look at the code. In the code, I have defined trigger pin as 6, echo pin as 5 and buzz pin as 13. Here we are also using serial monitor for getting distance output. So we set the baud rate of serial monitor at S9600. Then setting input output modes of pins, we have set trigger pin as output, echo pin as input and buzz pin as output. Buzz pin is output to control the buzzer. In the loop function, we have taken variable as duration, which is used for calculating time for the echo to get received by the echo pin, and another variable as distance, which is used to get the distance in centimeter. First of all, we put trigger pin too high. It will remain high for a time span of 1 second and then it will become low. Then we will receive the echo from nearby object and calculate the duration. This duration is used to calculate the distance in centimeters. So now these are used to print the distance on the serial monitor. Now we have set buzzer to beep at a maximum distance of 125 centimeter. That means if the distance exceeds 125 centimeter, then the buzzer will stop beeping. If the distance is less than 125 centimeter, that means our person have come some another person in his proximity of 125 centimeter. So the buzz pin will get high. Remember that the buzz pin is set to 13 and 13 is attached to both the buzzer and the LED. As the buzz pin gets high, the buzzer will start beeping and the LED will start glowing. If the distance now becomes greater than 125 centimeter, the buzz pin will remain low and hence it will make no indication. Now let's have a look at the working. Here if Click on the sensor and start increasing the distance, we see that their buzzer will remain off. But if we start decreasing the distance, and as soon as the distance gets 125 centimeter or less, the buzzer will start beeping. And as I increase the distance again, the buzzer stops beeping. One may repeat this process again and again. We can also see the exact distance at the serial monitor with the graph being plotted.